Okay, to name this angle 4 different ways. You can name it by its vertex. So the vertex is at y, so angle y. You can name it by the number that's inside, which is angle 1. You can name it by doing x, y, z, because y is the middle letter, because it is the vertex. Or you can go the other way and go z, y, x, angle z, y, x. So the only times you can name it by angle y is if it's the only angle there. So you couldn't call, if this was angle y right here, you couldn't call this angle y because we don't know which one it is. Is it this one or this one? So if there's just one angle y, you can name it by its vertex. Acute angles are angles that are less than 90. So less than 90 degrees. Obtuse is more than 90, greater than 90, but less than 180. Right angles are 90 degrees. They have this symbol right here, which means 90 degrees. And a straight angle is 180 degrees. It's like a line. Measure each angle using a protractor and classify each. I'll link up a separate video on measuring with the protractor, but classify each means tell me, is it acute, obtuse, straight, or right? This one is obtuse. It's greater than 90, less than 180. This one is acute. It's less than 90. This one looks like a right angle. And this one is a straight angle because it is 180 degrees. Just like with segments, angles are the same. Segments are congruent if they're equal. Angles are congruent if their measures are equal. Again, be careful with the notation. This is how you'd write the notation. The measure of angle ABC is equal to the measure of angle DEF. Measures are equal, therefore the angles ABC are congruent. So you couldn't say, this is what wouldn't work, you couldn't say the measure of angle ABC is congruent to the measure of angle DEF. You can't say the angles are the measures are congruent. You also couldn't say angle ABC is equal to angle DEF. The angles are congruent or their measures are equal. You can't flip-flop the notation. Similar to the segment addition postulate, the angle addition postulate says, or is, if you have A, B, C, D, the measure of angle ABC, right here, ABC, plus the measure of angle, make sure you put your measure symbols in, the measure of angle CBD is equal to the whole thing, which is angle ABD, just like our segment addition postulate. Okay? So, example 1 says solve for x, find the measure of angle, basically find the measure of these angles, all 3 of these angles right here. So, given that this whole thing is 9x plus 40, ABD is 9x minus 40, I'm going to write that in my diagram. Now, just like we did the angle or segment addition postulate, I'm going to write the measure of angle ABC, which is this one, plus the measure of angle CBD, CBD, equals the measure of angle ABD. Okay, it doesn't say I need to write justifications, but the justification for that is by the angle addition postulate. So next step is I'm going to substitute. ABC is 5x plus 2 plus CBD is 3x plus 1, and that equals the whole thing, which is 9x minus 40. This is by substitution. So if you had to write justifications, the justification would be substitution. And now I go ahead and just combine like terms. So it's 8x plus 3 equals 9x minus 40. And then that is by the addition property or substitution or combine like terms. Now I'm going to use the subtraction property of equality. So I have 3 equals x minus 40. Then I use the addition property of equality. So x equals 43. So if x equals 43, I need to plug in 43 in here for x, 43 in here for x. So you can go ahead and plug those in and get the angle measures. There's 4 different important angle pairs. So a pair means more than 2. There's 2. So vertical angles are if you intersect 2 lines, the angles that are opposite are vertical angles. Okay, vertical angles are congruent. So the blue angles are congruent and the red angles are congruent. Adjacent means they're angles that share the same vertex right here and the same side. So an example of a non-adjacent would be if you had this red angle and this blue angle. They don't share the same side. They share the same vertex, but not the same side. Complementary angles are 2 angles that add up to 90 degrees. They do not have to be adjacent. They don't have to. They can be. Here's a pair of complementary angles that are adjacent. Here's a pair of complementary angles that are non-adjacent. Same thing with supplementary angles. Supplementary angles can be non-adjacent, or they can be, so these 2 are non-adjacent, or they can be adjacent. So 140, 40. They make a line. Okay, so supplementary adds up to 180. Complementary adds up to 90.